Hi, good day. My name is Padilla John Michael Gabrielei, and I am in the class of ECEA 103L, section E01. And for this experiment, experiment 6, I am here to discuss the PLC diagrams I have created in the previous experiment. So, let's get right into it. So, recalling the previous experiments, we have three problems that we actually have to solve. So in experiment 4, we had to create a relay ladder diagram, and in experiment 5, we had to convert those ladder diagrams into PLC. So for the first problem, the first problem states that make a ladder diagram having three switches, S1, S2, and S3, and one buzzer. The buzzer can only be activated by pressing any two switches. Pressing one switch or all three switches will not activate the buzzer. Show the truth table, logic equation, simplify, and convert to PLC. So that was our first problem for experiment 5. Now, going back to experiment 4, we already created the truth table, and we already used K-map to obtain the equation of this problem, which will later on help us in programming the logic module. So here we can see that we already have the truth table, and here is the ladder diagram for number 1. Now, going on to the circuit that we made, so as seen in the experiment file, we have three parts that we actually have to do when creating a PLC. So first, we have to show the input and output wiring. Next, we have to show the input and output assignment, which is commonly a table. And lastly is the PLC ladder diagram of the circuit you're trying to make. So going on to the circuit, so here we can see that a 24 volt source is plugged into the 24 volt port of the logic module, and a 0 volt source is plugged onto the 0 volt port of the module. Now, since we have to first show the input and output wiring, so here we can see that we have three switches, and those switches are XYZ, which is also known as S1, S2, and S3. So those three switches are wired into the input portion of the logic module. And we have one buzzer, and the buzzer is wired onto the output section of the logic module. So that is the input and output wiring for this problem. Now, for the next part, we need to look at the input assignment. So for the input assignment, we can see that here we have the device. So the device is actually the switches and the buzzers that we used as input and output devices. So we have X, Y, Z, and a buzzer. So the address is actually it's actually like a code that will tell us where we wired the um, the the said device, the said input or output device. So looking at this table, we have all our input devices and our output device. Now moving on to the next part, which is the PLC ladder diagram. So in the PLC ladder diagram, this was actually created with the use of the equation that we obtained from the K-map. So using this equation, we were able to create a logic circuit. Here, we were able to create a logic circuit, and that logic circuit was programmed inside the logic module in order for our PLC to work the way we want it to work. Now, testing the circuit, So as mentioned in the problem, only two switches, when two switches are pressed, that is the only condition that will make our buzzer turn on. Now, as we can see, if we press X, if we press only one, so the buzzer is not turning on, but if we press another switch, the buzzer turns on. Now, we can try other outputs, other inputs. We can say that we can use Y and Z, and as you can see, the buzzer is still lighting up. So, based on the results we're getting from this simulation, we can say that we have programmed the PLC, or the logic module rather. We have programmed the logic module in the correct way since we are able to satisfy the conditions of the problem in the first part. So moving on to the second problem. So the second problem states that make a ladder diagram which contains two lamps L1 and L2 and two switches S1 and S2. S1 momentary switch will act as the start switch while S2 toggle switch will be the selector switch. If S2 is at off position and S1 is pressed, L1 will light up. On the other hand, if S2 is at on position and S1 is pressed, L2 will line up. So, show the truth table and logic equations, simplify and convert to PLC. So, in creating the PLC diagram for this problem, we can just follow the same steps that we did on the first problem. So first, we need our input and output wiring. So going onto the circuit here, we can see that on the 24-volt port, again, to power up the circuit, we have a 24-volt source wired to the 24-volt port and a 0-volt source wired onto 0-volt port of the logic module. Now on the input section, I0 and I1, we have S1 and S2, and on the output section, we have our L1 and our L2. So now that we have our input wiring, we can again proceed to the input and output assignment table. So we have already created that. So here we can see that we have our devices listed again with their corresponding addresses. So 0.00 corresponds to I0 of the input section of the logic module. 0.01 corresponds to I1, so and so on and so forth. So S1 is wired onto 0.00, S2 is wired onto 0.01, and we have our description. So the two switches that we used are normally open push buttons, and the two output devices that we have are 24-volt DC lamps. So now, after creating the table for the input and output assignment, we can now proceed to creating the PLC ladder diagram. And again, we can create the PLC ladder diagram using the equations that we gathered from the truth table and came up of the problem which we have created in experiment 4. So here we have our equation for the first input, which is L1 is equal to S1 and S2 prime, and L2 is equal to S1 and S2 prime. Now using those two equations, going onto the circuit, so we can see that inside the logic module, using those equations, we were able to create this logic circuit which is consist of two AND gates. Now to test whether if we satisfied the condition, so basically what needs to happen is that if S2 is not pressed and we press S1, L1 should light up. So let's test that. So here, as you can see, we're not pressing S2, and when we press S1, L1 lit up. So we satisfied the first condition. Now let's see if we can satisfy the second one. Now if we press S2, so if we press S1 now, L2 should light up. So if that lights up, we can say that we satisfied the condition. So if we press S1, as you can see, L2 is the one lighting up. So looking at the results of this simulation, we can say that we have satisfied the condition that is stated in the problem. So it means that we again correctly programmed our logic modules since we were able to satisfy those given conditions. So moving on to the third and final problem. So the third problem states that lamp A turns on when PB1 is pressed and even when released. The same thing happens to PB2 in controlling lamp B. Each lamp will only be reset by PB3. The first PB to be activated will disable the next PB until PB3 resets the system. Make the ladder diagram and convert to PLC. So as you can see, so here is our ladder diagram that we obtained from experiment 4. So this problem is actually a bit complicated since it is dealing with latching relays. So as you can see here, we have um, a ladder diagram that exhibits the characteristics of a relay latching circuit. Now, in order to create the PLC for this problem, again, we have to follow the three steps that we've been following for the previous problems. So first, again, we must show the input and output wiring. So here, again, to power up the circuit, we have a 24 volt and a 0 volt source, and it is wired to the 24 volt and 0 volt port of the logic module. Now, onto the inputs, so we have three inputs. We have PB1, PB2, and PB3. And on the outputs, we have two outputs, which is lamp 1 and or lamp A rather, lamp A and lamp B. So those are the inputs and outputs, and this is the wiring of those inputs and outputs onto the logic module in FluidSim. So next, we need to show the input and output assignments. So here we have the table for that. We have our devices PB1, PB2, PB3, L1, and L2, and these are their addresses. So these are addresses that correspond to um, certain input ports in the logic module. So next, the address, again, we have the description so that we know what kind of device are we using in our logic module or in our PLC ladder diagram. Now, next is of course, the last step in creating a PLC ladder diagram is the programming of the logic module. So looking at the circuit again, so opening that, we can see that we have our logic circuits, and since we are dealing with relay latching circuits, we have here um, latching relays, two latching relays. So the logic circuit for each input is wired onto the latching relay block. So here we wired the logic circuit for the first input, which is PB1, and on the other uh, relay latching block, we have wired the next input, which is PB2, the logic circuit of PB2, onto the other latching relay. Now, since the latching relay block has two ports, the second port is dedicated to the third input, which is PB3, since based on the condition we need to satisfy stated in the problem, PB3 needs, or PB3 rather, is the switch that will reset the whole system. So that is why we connected it to the other port of the two relay latching, latching relay block. So here is the circuit, or the logic circuit that is used to program the logic module and to simulate. So basically, what will happen is that if we press one push button, it should disable the second push button. And not only that, not only should it disable the second push button, but the lamp should um the lamp should also be turned on, or should stay on, even if we release the switch that we pressed, because that is the characteristic of a relay latching circuit. So a relay latching circuit is a circuit that still satisfies the condition even after you release the switch, or even if you change the input. So to simulate, here we can see that if we push button 1, lamp 1 lights up. So since lamp 1 lights up, so to see if this is a relay latching circuit, if we release this, lamp 1 should stay on. So if we release push button 1, as you can see, lamp 1 is still on. And for the second condition, the first push button that you pressed should disable the next push button, which means that if we press PB2 here, push button 2, nothing should happen. So if we press push button 2, as you can see, nothing is happening since it was disabled by push button 1 according to the second condition given in the problem. And the last condition for this problem is that PB3, if you press PB3, it should reset the entire system. So if we press this, we can see that lamp A is no longer turned on since we pressed PB3, since PB3 is the reset switch of this circuit. Now let's try it. If we press PB2, we can see that when we press PB2, lamp B is the one turned on, and if we release PB2, it is still turned on. And since PB2 is the first switch that we pressed, when we press PB1, nothing happens. So it satisfies the first two conditions, and again, if we press PB3, it resets the system. So that is the um, circuit that is used to program this logic module. And looking at the results of the simulation, again, we have correctly programmed the logic module, which means that we made the correct PLC ladder diagram for this problem.